who here has ever done property-based testing, used property-based testing? Raise your hand. Oh, okay, so quite a lot of you. Have heard about it? More. Hi. Thank you.
Wonderful.
Ever tried a tutorial of it? Okay. So the reason I do this talk is because I use property-based testing a lot. I love it. And every time I tried to go to look at a tutorial of it, I always had the same recurrent problems with the tutorials. One, it was always in an awesome language, right? Haskell or something like that. And most people don't use them, right? Who here actually use an awesome language at work? I envy you all.
But you put your hand up yourself.
No, I just gave an example. And so lots of people don't use them. Lots of people are using Java or C# or things like that. I'm not saying that Java or C# are bad per se, right? All languages are bad.
What language do you use?
I hate all languages equally. And I will not create a parenthesis about this, but I would argue that we are still in the infancy of creating languages. It's someday, in some powerful future, we'll start having good ones. Not there yet. So that's the first problem. Second problem is that usually tutorials go about with some very basic examples about I don't know, addition or some mathematical things like associativity or things like that. Things that are very useful, things that I do test a lot actually, but things that a lot of people don't really inherently feel comfortable with, right? So that's why I started talking about this, because it's a shame really. Property-based testing can be used in a lot of different ways, with a lot of different properties. And you should be doing now. And it can be used in awful languages, and can be used in awful code bases. And as a matter of fact, I love using property-based testing with 12-year-olds, 15-year-olds legacy code bases that are done in Java 6 or something like that. Right? And it works quite well. So let's start changing about this. What is property-based testing for you? Most of you have heard about it, so what is it? What is it?
A way to test the invariants in your code.
Oh, the way to test invariants. Well, so a way to test invariants. So this presentation will contain typos. I know what is not. Property-based testing is not formal verification. Actually, if you went to the awesome keynote this morning, it was said that it could be used in tandem with formal verification, but it's not formal verification itself, right? It's a way to verify things, but it's not formal. So I will not ask what is formal, because this will be another presentation, right? So it's testing with properties. So what is a property? We'll discuss a lot about that. So I would argue that property-based testing is like insurance, and that all insurance is a bet. When you have an insurance policy, you're betting every month, I will have a arson or someone will steal my apartment this month. You bet this with your insurance company, and the insurance company bets that you won't. And you lose the bet, and you're happy to lose it, right? That's the basic principle of insurance companies. It's a kind of a casino with different stakes. And property-based testing is kind of a casino of different stakes too. Like an insurance company, you're telling, I think this is true about my code. And the property-based test framework tries to prove that you're wrong. Tries to show you that that thing that you think is true about your code is actually false. That's the gist of it. And it tries to do that using entropy, using random generation. And I'll try to argue with you that this is a good thing. So, it is a bet. You are betting that a thing that you think is true is true. The framework is betting that you are wrong. So, let's talk about properties, right? Why property-based testing? So, 3 little words I will insert into this discussion. They will not have formal definitions in this discussion, but because this is besides the point. I will just a working definition here with you people, okay? Tautology, invariant, and property, okay? So, I would say that as a tautology is something that is always true, yeah? I would say that an invariant is something that is always true. And I'll say that a property is something that is always true. But different kinds of always. That's the gist. for different definitions of always. So a tautology is really absolutely always true, right? When you go downwards, you're going down. Otherwise, it would not be called going downwards, even if in other positions you could see that movement as up. If you call it downwards, that it is in your definition down. This is a tautology. Very useful. Well, we'll come back to tautologies later. An invariant is something that within a context, a working definition, people, there is a mathematical definition you can search on the internet. Within a context is always true. When you say I have this preconditions, this postconditions, I have this invariant in the middle that works out, right? This is an awful definition. I'm just trying to be quick here. And a property is within an invariant something that we remark about that invariant. One invariant can have many properties. Also a very bad working definition, yeah? So why is this important? Why should I talk about things that I think are true in properties of my program? Why should I care about this, right? And I promise you, this will be the only very theoretical part of this presentation. Be strong. So, hi, I'm Romeu. Oh, God damn it. I work at BCG. I organize a little conference in France that you should totally go there called Ncrafts. And you can find me on Twitter as Malxameth. This dude. And there is a dude called Peter Gardnerforth that wrote a book called The Geometry of Meaning. Don't know if you're into linguistics or things like that. But it's a very interesting book if you're into linguistics and things like that. And in this book, he tries to argue two very, very important points. One, that linguistics are cognitive sciences. It's not they are, you can infer one for others, is that the two are the same. So when you use language, you are actually using your way of thinking. It's not one uses the other, both are the same thing, right? So the way you conceptualize things is your way of thinking. This is important. Means when you talk about naming things is the harder problem in computer science, remember that saying. You are actually talk about conceptualizing is hard, okay? So he talked about quality dimensions, about domains, about properties. He says a quality dimension are things like pitch, temperature, weight, right? A domain within a quality dimension is like space, height, width, depth, or color, or saturation, or taste, or emotions, right? A domain is a large thing that encompasses all this. I'm trying to be quick about the theoretics here, but if you have questions about this, interrupt me. And he come to a realization that I find quite interesting, which is A property is a convex region in some domain. Yeah, it's clear to everybody. Oh, I cannot copy paste. Oh, I can. I'll copy paste it. So, oops. So he said that something is convex that when you have between 2 points x and y, all points between them are also in the same subset. So this is a very mathematical definition. Let's try to make this more clear. When you are looking at this is a geometrical metaphor. When you look at some region, if you can say between those 2 points, everything between them belongs in the same area, you're saying this is a convex region. Okay? What is this useful? What you're saying is, when I have this thing, I'll have the notion of weight or the notion of happiness. Any word that I can put inside that notion, if I have those 2 words that are within the same notion, any 2 words between them are in the same notion, then everything is within the same notion. Well, the usefulness of this is that every time you can draw an area, you can draw a diagram saying these all words here are similar, you're creating a property. So this all seems very abstract. Let's go back to real life. Ever try BDD, behavior-driven development? No, someone? Okay. Ever try to discuss a business rule with someone from a business? Ever had a business? Okay. Okay. Every time you discuss with someone from the business, saying, explain to me what you want to do, the person is never giving you very specific, concrete examples. That person is trying to give you a generic rule. Yes? That's normal, because that person is sane, is a normal human being. And the person is just trying to explain to you, yeah, well, yeah, what happens is, I don't know, what is a business rule in your domain? Who has business rule here?
Usually, the volume of a trade is constant for this contract.
Volume of a trade is constant for this contract. Or a child that takes too much doliprane dies, right? I mean, there are very specific phrases that you can bet in the domain, in the business domain, are always true. Yes? Remember what I said earlier. As soon as you have a phrase that you think is always true, you can design it as a property. Hence, you can make a bet that is always true in your code base. That's the usefulness of it. So, let's talk about code. Ever played bowling or did bowling kata? Remember the rules of the game, more or less? I will not bore you with all the rules of the game. The whole idea here is, if I were to try to do the calculation of bowling, I will have 3 main cases: nominal case, spares, strikes, right? When I have bowling, I rolling balls to try to put down pins. Yes? I have 10 frames in a game. Each frame I have 2 balls. And they all go down. Well, no, they don't. I try to make them all go down. And I have 2 tries per frame, 2 balls I can try per frame. My score is the number of pins I can actually go down. That's my nominal score. Unless I can make them all, the 10 balls go down at the same time in a single frame, then I have a spare. In the case of a spare, my frame score is 10 plus the next ball. And in the case of a strike, where in my very first try, I put all 10 balls down, I use the next 2 balls, yes? So, if I were trying to do this in the TDD way, I would first make a test about I put no balls down, which incidentally in real life is a score I already had. Then I will put something like I made some points. Then I will try something like a spare, something like a more complex spare, a strike. in the perfect game, which I never had in real life. And you go from example for example, trying to make this all work, and then you have all these tests that pass. Yes? This resembles a little bit the tests you have today in production. Raise your hand if it's the case. Liars. Liars. I don't believe in you. I will argue that your tests, if you're using C# or Java or something like that, your tests probably resemble a little bit more something like this. Does this rings truer? Yes? This is neither a bad or good thing. I just stating that I think this is more similar to real life. We'll go back to this one. So when I do this, what I'm actually doing is saying, I think all those examples are representative. You're doing representative democracy for your examples, right? You say these examples represent all other examples that are similar to this. Yeah? What you're actually doing is more or less taking random examples at developer time. Yeah? The moment you're writing the code, you took a random example and say, this is representative of the others that are similar to this, and this is good enough. Yeah? Okay. So you can say, Romeu, I could easily cheat here and write a code that only takes those inputs and give those outputs and does nothing else, right? And you could answer, I could answer yes, but if I don't do this, then I cannot just do one example for every possible input to this, right? It would be strange. And one could argue, yeah, but you could at least give some more examples. And then you have things like parameterized testing. I give several inputs of the same kind and try to say they have the same behavior. But then I made a jump here. Here, inherently, I'm testing these input have this output. Input, output, input, output. Here, I'm testing those inputs have this behavior. Inputs, behavior. Right? Unless I pass all inputs and outputs as parameters, but in that case, why? And I'll get to this, I'm no longer testing the same thing, and the nature of the thing is no longer the same. Here, and I'll argue that the purpose of your test is to help archaeology. I mean, it's also nice that it helps test your code, but that's bonus. The main purpose of a test is because somehow, somewhere, people will get to read the code later, and they actually need to understand how it's used. And I argue that most people doing codes professionally today spend an inordinate amount of time doing archaeology, trying to find what they did or not. What people before them did or not, how is other people. I argue that someone that never knew the rules of bowling, when they arrive at this test, will be kind of flabbergasted at first to find the rules of bowling. Yes? The person would have to, I made on purpose to choose very bad names for my tests. This, fair warning, every single example of code in this presentation is all for one purpose. Because I wanted to show you that you can use it even in alpha code. Okay, there is code that is worse than this easily, but it will get in the way of using the presentation, right? So I try to strike an equilibrium here, a balance. So the names don't help you because sometimes they don't. So you try to find what are the rules of bowling by reading your tests and say, oh, I have those, this here gives that, this here gives that. And by those two examples, you have to presume that in many cases you have a sum. Yeah? Ever felt that situation in your life? You have decades maybe of business rules that were decided, they were not all documented, they were not all kept. And it becomes very difficult to know when you look at something strange in the code whether someone did something wrong or whether this was an edge case in the business side, right? That it becomes different. But the code itself starts to have many business rules inside it that nobody else understands or knows. The code is probably older, in many companies, older than the domain experts themselves are in the company. So the code will know things that no human being in the building know about the business rules. But you have to extract it somehow. Yes? So, one could say that this is slightly better, right? I now have all those things that I can compare between them to try to find what do they have in common. And I now have a very specific rule written about what is the behavior of the code I want. So I have like half the path is there. It just sucks though. I hate this. Why? One, I'm lazy. I don't like write all of this. Two, this should not be possible. Never have 12 pins. It shows, and it keeps showing that I have a very big problem of designing my code itself. This code is very badly designed. It's very primitive obsessive. It's trying to use integers for everything and it's right. And I can have blatantly false things that pass my tests because all go green. All goes green here. Yay. Oh, no. Never saw that. So another problem completely separated from this. So, one step further is property-based testing. It's saying, I know this is true about my code, and try to find counterexamples of it. Try to do random inputs that are counterexamples of it. To find counterexamples of it. You cannot try all the possible inputs because that will take a long time. So each time you execute your tests, you're getting like 100 tries. You can actually configure it. You get 100 tries, and that 100 tries will try to find something that goes against your rules. And if it doesn't, it could, let's say, is green, which is a very perfect first law of the thing, which is when a property-based test goes green, it isn't it passed. It is I could not get you this time, but maybe the next one. What I argue is this is always the case. Any test you ever write will have exactly same premise. When you this awful Java 6 test here, model test. What it says is, when I go green, it doesn't say this is true. It says, I could not have you this time, but maybe next time I will. But it keeps trying the same thing. It tries the random input you decided at coding time. That's all. You did that, like you talked about, you did that representative democracy of examples when you did this. You elected one example to represent all others. You keep trying that one and say, ha, I did not got you this time, and maybe the next time around. Right? So, here, what I'm saying is, let's be more honest, right? Let's put random shit in it. And as soon as that random shit enters into what I define as being my preconditions, then is a valid input, and all valid inputs should work. Yeah? But then something strange happens. I started having the same preconditions in every test. This is to show what is obvious in the beginning, but now it becomes kind of hard, which is, I actually had a type or a value object or something here that should exist, and it doesn't exist today. My design is pretty primitivist. Yep. So, as I said before, real life is more like this, right? Do you have tests like that? Raise your hands if you do. Oh, yeah, you do. It's like I have this input that I put in this input, that I put in this input, that I put in this input, this object, and this object, and this object, and this object, and this object. Oh, I don't care. And I put all this as an input to a call that I try to see the result is that, right? And most things I'm using, I'm not caring about. It's just, I needed a patient, so I created one. Nothing here is very important for me, from my test. Yeah? And I needed this. Maybe one of those is important, and all the others aren't. You have many mandatory inputs, and you just put random shit at code in time. Representative democracy, right? And as you already guessed, the only important thing here was this, right? I mean, it's obvious to everyone. Because it's the only one that is different from here. Now, of course, you could tell me right now, but Romeu, I mean, this is fault of your ugly code. I could do the same thing more beautifully, easily. Many other ways of doing this. There is a building pattern, there is I can have fixtures, I can use a different language, etc., 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 right? But what I try to convince you is that when you do example-based testing, in the end, what you're doing is more or less this. In a more beautiful version of this, but more or less this. I'm not saying that beauty is not important. I will never diss on beauty. Beauty in code, like in flowers, is there to ensure the means of reproduction. But beauty by itself will not solve the problem that you're still doing representative democracy into your code test examples. Yes? The inherent problem here remains the same. So, this test, this is actually, I had a client that allowed me to use his 12-year-old's code base in my talks. It's very brave and very generous of them. I realized that I couldn't, because actually using the real code base in talks required much more time than I have in a talk. So I started taking and doing lighter versions of what I had in codebase. So the essence of this comes from a real code base. And the person that coded this really believed that they only had two cases. Dosage was the only thing. What I'm trying to say here is that is the business rule that says when my dosage is too big, I have an alarm that says your baby dies, or someone dies, the patient dies, okay? And they only believed that dosage was the problem. This was tests added after the fact. It's not TDD, not type-driven development, it's just I have tests and I added them. And they were wrong. They were badly wrong. You can actually easily create other examples. I can easily give prescribe a very normal dosage and say you take this too many times a day and it will still kill you, right? And there are many other ways of doing this that are wrong. So the real code has way more business rules than this. But this, hopefully, still goes green. And the person can convince themselves that, hey, the spotlight effect. I'm testing everything I could think of, and this seems to be enough. Seems right to me, right? Whereas, if you really think that none of this matters, if you really believe this, then it becomes an invariant, right? Something that you believe is always true, yeah? Then, if you believe that, you can use property-based testing. You can bet that I believe those things don't matter. And if you believe in that, then you can just change every one of them by random, yes? If they don't matter, they could be replaced by random. And it should not change the nature of the test itself. I could make this single line exactly like this and put random in everything else. And it should be the same test, yeah? Well, if I did that, and this is also awful, I get a red. That is what I'm trying to convince you to do Monday. You already have most of the bodies of your property-based tests today, if you have tests in your code base. You have a very quick switch to do to put randoms in places where you think this doesn't matter. And if you put those randoms and they don't matter, this should not change your test. And if it does matter and it goes red, you should take a look at your assumptions. And that's the thing. If each time a property-based test goes red, it either tells you that you had a bug in your code, or tells you that you have a bug about your understanding of the business. You don't know beforehand. You found a counterexample. Your assumption is false, either because the code is bad, or because your assumption is bad. What you think is true is not. Right? So, once you do all that, why? Well, finding bugs. Finding bugs is fine. Finding bugs is cool. I have 4 ways to use this that are very different. Myself, 4 plus 1. I'll enter in the 5th one later. One is to find emerging properties. I just did in front of you. I had tests that were not property-based tests, and I tried to merge them together to the point I have a property-based test. When I do this, I just discovered a property that I did not know before about my domain, or I did and I could not put it. But I make them emerge from existing tests, right? Another usage I have of this is when I have a business person that say, oh, this is my business rule, and I have to implement it. Then I have what I call a double loop test. I have a test that is red, and it remains red a lot of time, and I'm working inside of it until it goes green. It's a very far horizon, and I could do many other types of tests or no tests inside it. Another thing I do this is to ask questions to my code base. As I said before, the code base will know things that no human being in the building will know after some years. So I can use it to ask tests to the code base. Does this behave like that? And the code base will tell me. Do I have this business rule? And the code base will tell me. And I now have a new member on the team that I always had and you can ask questions to. And this is very powerful. Another way is to do characterization tests. I don't have any idea, it's not, I can ask a question about the domain, I have this piece of test, and bear with me, I have that problem, I don't know if you had. I have no friggin' idea of what this does, right? I have no test, nothing, I just have this, and it's quite incomprehensible. So I start creating tests that I throw away, that are just there to enlighten me of what is the behavior of this. And I use property-based testing a lot to do that. And how many time do I have?
You've got about 10 minutes.
Oh, that's fine. I just thought you say 5. I was, So, at this moment, usually I have very frequent questions. One is, isn't this less sure? I mean, I'm using random as input. Isn't random bad? Right? And I will put down to this. You can, if you're really afraid, you can really mix put in some fixed and what you don't care about random. But in the end of the day, you are not testing less things that you're testing today. You're testing more things that you're testing today. And those things will have the same behavior of the test you have today. You're switching from coding time random inputs to compile time random inputs or to execution test time random inputs. That's all. You're just switching one layer of what is random. You still have the same level of randomness in the worst case scenario. Okay? Another frequent question I have on this is, what if my current tests are slow as hell? I mean, you said, Romeu, that I have to execute each test like 100 times, 100 different inputs. My current test today takes like a half an hour to execute, right? I would hate using this in my current tests. Well, I have two answers to this. One is not very helpful, which is you should fix your tests. The other is a compromise, which is if executing it 100 times is impossible for you, take your current slow test, put randoms where the things you don't care are, and well, try it once. It is not good, but it's better than what you have today, right? So it's a light improvement already. I don't know why I have this question, but I usually have it, is what if everything is green on my machine when I'm coding, my tests all pass in my machine, and then I put it in a continuous integration pipeline, try to make a build, and then the build fails? And my answer is, you do exactly what we would do if the build would pass, and you have some QA people arrive and say, hey, I found a bug. There are only two things you can do at that moment. Make stop the process, or say, I will look at this later, right? More or less the two things you can do. Because if you execute again, you won't have the red, or you have all the time you're not really green in your machine. The probability of executing again not having the red are very strong. You just take the example and keep to do a test. That's also something later that you do, or you answer it right now. There's only two options. But tests do not break your code. Tests breaks your illusions about your code. That's the same thing. Reasoning about your code does not make your code weaker. They just give you more information about it. That's all. And that's most of what I like to talk about, because you're not really in C# or Java or something like that, because I would talk about generators, but if you're F# or Haskell, you don't really need them most of the day, right? It's like bad languages did that. Like the examples I just gave, I really don't have a way to infer things with the types, so I have to make do with created by hand generators to things. But generators are just copying your constructors and putting them with random inputs somewhere. It's just a copy paste from your current tests into another place where you put randoms input inside it, so you don't have to have it at same place everywhere. That's a very easy thing. As a matter of fact, even if you don't, you probably have, in any language you're using today, you probably have a property-based test framework, and you can just check on the internet, my language, and quick check, and you probably find something. But if you don't, creating one is not very hard. It's not a very, I mean, I thank you, Jean Hughes, for inventing this thing, but once you discover the genius idea of using it, actually implementing it is not a very complex problem. So, questions? Yes?
What is the word desolation?
Oh yeah, sorry. So,
What is the
what is
Voronoi
Voronoi tessellation? Yes, yes. I probably have forgot that here, right? Don't worry about that. So, Voronoi tessellation, when I talked about linguistics in the beginning, remember, talked about a property as being a convex region of a domain. A Voronoi tessellation is a way of visualizing those properties. I mean, if you try to represent them as a geometry, visualizing those properties. So you have convex regions of a domain, and to put them all together in a single domain, use a Voronoi tessellation, which resembles something like that. But it works if you're really into using geometry to explain linguistics, which is probably not the scope of this. Something else. I usually people, please try it Monday in your code bases. If you're not doing this today, this is not a formal method. This is not something that you can replace proofs of something like that. But this is something that you can use today with any code, without changing the code itself, in any language. That doesn't matter if the code is old and awful, etc., etc., etc. You just create a new test that uses the framework and start growing in your code with it. It's a very easy first step to oh yes, please.
So you told us about how you like property-based testing. Can you say something about the property-based testing community? How much is it really being used, or is it people who just love doing it, or some success stories?
Oh my God. This is like the 30th time I'm doing this talk, and I'm still trying to convince people to use this at all, right? I'm very frustrated by the smallness of it, but it's improving, right? Okay, I'm at loss of words here to your question, really. This is something that is shamelessly not used enough in the industry. It is used by a lot of people like me and other waiters, but the industry currently hasn't adopted it under the illusion of that this is not usable in the code base or in the languages. But I will take your question, as I cannot answer your question, unfortunately, what I can say is, when would I not use property-based tests? And talk a lot about things that is beautiful, is usable, etc., etc., etc. When would I not use the property-based testing? I would not use property-based testing when creating the body of the test would come up to the point where I would be using the same code that is tested in the test itself. If I cannot write a test that is different from the code being tested, then I would stop doing it. Why? Because then I will not test anymore the behavior of the test. I will test that I'm testing that the code has the same behavior as itself. The code has the same behavior as itself. That's a tautology. You can trust on that. You don't need to test that. And that's the reason why I will not use property-based testing everywhere. There are limits to where I can actually write an useful property-based test that is not a copy of the tested code itself. And when I do have that, then I'll boil down to weaker properties and to example-based tests. So I mix and match a lot of the two. This is not a tool that can replace every other test. It's a new tool in your test weaponry, but just one tool among several. And if you can pass to a language that have better type systems or better proof, you should totally do it. And it doesn't avoid you from doing property-based tests at all. Sorry, and thank you for your question.
Cool.
Any other question?
Sorry, that's all. I think, yeah, that's all we've got time for now. So
thank you very much,
thank
ladies
you.
and gentlemen.